Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Douglas J. Miller Elementary, home of the Mustangs, and we're here to... We're back here live at Douglas J. Miller Elementary School, home of the Mustangs, and it's such a beautiful day. We had to do some math outside today. At this point, we're going to see if we can work on some perimeter. So, everybody's got their whiteboards ready to go. First thing we did, and I really think this is something neat to show, if you still have your name on your paper, still have your name on your board, right? Make sure that you can hold that up a little bit so everyone can see your name, because we have some math signs taking place of the letters. And everyone got a chance to write their name, hopefully with a letter or some kind of math thing in there. We had some people with a cent sign, maybe even a dollar sign. And you got your name on there, but there's some math everywhere you go, right? There's some math all over the place. We have math in your name. We got math on the whiteboard here. We got math outside. No matter where you are, there's some math. But we're going to do, the first problem we're going to do is a perimeter problem. So on your whiteboard, right underneath your name, can you draw yourself a rectangle? And it'll look something like this. Ready? See if I can do mine upside down. A big, long rectangle. Oh, I got a little crooked rectangle, but you know what I'm talking about. Okay, so we have a rectangle there. I'm going to give you some measurements, and I'm not as worried about the answer to this problem because I know you're smart people. I'm really concerned about how you got the answer. So after you solve the problem, I may come around and ask you, how'd you get it? And when that happens, I want you to explain to me what you did, okay? So the long side on the very bottom, we're going to make that into 10 feet. Okay, 10 feet on the bottom. And then on the side, on the right side here, we're going to make this into 5 feet, exactly half of what you have there. So if you can find the perimeter of that rectangle that you have there, but also be able to explain it, anything at all that you can write down that would explain to me how you got your answer, that's going to be the most helpful thing. And you might get a different way of doing it than someone next to you. Are you ready? Okay. Explain to me exactly how you got the answer that you have here. What is the answer, by the way?
The answer is 30.
30 what?
Feet.
30 feet. There we go. And how did this happen? How'd you get the answer to that one?
First, I added 10 feet plus 10 feet. That equals 20 feet.
Okay.
I added 5 feet plus 5 feet. That equals 10 feet. And 20 plus 10 feet equals 30 feet.
Wonderfully done. Don't forget to put that feet on the end there. Who's got a different way they did it? They didn't do 20 plus 10. Oh, I see a different one here. Look at this one here. I see some 15s in here. How did that come up? How'd you get 15s?
Okay, so this is how I did it.
All right.
15 plus 15 is 30.
Yeah?
So...
But where'd the 15 come from?
10 plus 5 equals 15, 10 plus 5.
Right.
So 10 plus 5 is 10 plus 5, same as 15 plus 15. See, look.
I like how you explain that over there on the side, too.
10, 50,
Oh, and we're filling in the blank spots.
feet,
That's a really good thing to do.
10 plus 5 is 15.
Yeah, got to circle those two together. That's where that one came from. Good.
And 10 plus 5 is also 15.
Yep. And then you added them up together right there. Man, that's awesome.
Wait.
I think somebody over here has another way to do it. Who had another way to do it? Uh-oh, I see a whole bunch of numbers here. They're not even in a row. Tell us what happened here, Alex.
So
How'd you get this one?
You added 10 plus 5 plus 10 plus 5.
You just kind of went around all the way around the rectangle, right?
Mm-hmm.
So what's your final answer?
No, this is 10, so it's 10, 20, 30.
30. 30 what?
30 units.
30 feet. Oh, yeah.
Yeah,
Kind of ran out of some
30
room there.
feet.
All right. So I'm going to pick on this table in a minute here, but I'm going to change your problem. Are you ready? Don't erase your rectangle, but I want you to erase a corner of it. Okay, watch this. This is going to be a really neat way to do this problem. Okay? We're going to take out a corner. And so the problem, or the picture is going to look like this. Okay? You see that's a rectangle with a chunk cut out of it? Now, I will tell you here that this over here is 3. Is that a 3? Oh, it's a backwards 3. It's a 3 to me. This over here is 3 feet right here. And this one here is 2 feet. And this part right here, this part, and this section right here is going to be 4 feet. So before you go about figuring out what the perimeter is of this problem, let's see if we can together figure out what our missing part is right here. Up here, we're missing a piece. Don't you agree? Mm-hmm. We're missing a piece. So if the entire bottom of this rectangle is 10, and this piece is 4, how much is left?
6.
6. Good job. So we have 6 feet up there. Now you have all the pieces. Can you tell me what the perimeter is of this shape? Let's see what you got. You got some good pictures there. And there may be a different way to do this problem than the way that we did the problem before. Oh, I hear some talking. I hear some thinking. Hear those wheels turning. I appreciate the way you're thinking. Who can explain to me what they've done? Okay, so what's the answer?
So what I got is 30.
You got 30. That's the same thing they got over there. You better be able to prove it.
So what I did is I did 6 plus 4,
Okay?
and it equaled 10, and
Good.
then I added 2, which is 12, and
Yep.
then I added this 10, which was 22,
Yes.
and then I added the 5, which was 27, and then
Yep.
I added this 3. And
So if you add them all up together, in whatever order it is, it happens to be 30. Right? Anybody else have a different way of doing it? Did you do it the same way they did before? Because we got the same answer. Isn't that interesting? Allison, look at your picture here. This is a really neat deal. This is 10 on the bottom, right? But 4 plus 6 is also 10. This is 5 on the right side, but 2 plus 3 is also 5. So we have a picture that's very similar to what we had before. Even though there's a chunk out of it, it still has the same perimeter. Isn't math amazing?
Yeah.
That's unbelievable. We need to do some more amazing math. Hey, we're back here at Miller Elementary, still outside, still doing some math, home of the Mustangs, and these guys are excited to do another problem. We're not going to do perimeter this time, though. We're going to do some multiplication and a little real-world application of multiplication. We want to do some rounding first. Okay, so everybody ready to go? Yeah. Get your whiteboard ready. Okay, we're going to do some rounding multiplication. And I'm going to give you some real numbers, but before I ask you to multiply those numbers together, I want you to round them first, okay? The first number I'm going to ask you to multiply is 412, okay? 412, there's your big number, okay? And the other number I'm going to ask you to multiply that times 8. Please don't do the real problem yet. I want to see your rounded answer first, okay? So before you do any math at all, can you please round 412 and also round 8 if you think that's something you can do. And I think it's something you can do. And then I'm going to ask you maybe what you rounded to. Ooh, this is fantastic. Good work so far. So first of all, Karis, can you tell me exactly what you rounded 412 to? What did you round it to?
I rounded it to 400.
400. So what place value? Oh, 410. So you rounded it to 410. What
And
place
400.
value? And 400. So if you were going to use the number 400, what place value would you be rounding to?
Huh?
What place value? What place value is the 4 in?
100.
That's right. And if you were rounding to 410, what place value is the 1 in?
110.
The 10s, that's right. So if you're rounding this one to the nearest 10, it's 410. If you're rounding it to the nearest 100, it's 400. Who's got the 8 rounded for me? Someone's got, okay, let's see what we've got over here. You rounded the 8? What'd you round the 8 to?
I rounded the 8 to the 9.
You went to a 9? What the heck? What place value are you rounding the 8 to?
I'm rounding the 8 place value to.
It kind of stays in the 1s, huh? This is in the 1s and this is in the 1s. What would happen if you rounded it to the 10s place? What would happen there?
I rounded it to the 10.
Yeah, what would happen if you rounded 8 to the 10s place? Jack, you got it? If you round 8 to the nearest 10, what do you get?
10.
You get 10, that's it.
Because
And tell me what's in
8
this
is
spot
close
here.
To 10.
Yeah, that's right. Tell me what's in this spot before you round it. What's in that box right there?
What's in that box? It's the 10s.
It is the tens place, but what number is there? It's a 0 right now,
zero,
right?
yeah,
And you rounded it because the 8 made it go up to 1. Okay, so now you
I
have.
rounded it because 8 is very close to 10. 8,
That's
9,
right.
10. Only
It's real
3.
close. So we're going to make it into 10. Okay, so now I want you to give me a rounded answer for the whole problem.
Oh.
A rounded answer for the whole problem. Here's a wonderful answer. 410 times 10. How did you do that problem?
So you see, there's 1 times 1,
Yeah?
which is 1,
Right,
and then
right.
this would, and it's 4 times 1, but
Yep.
I have to move it to the thousands.
Good. And then where'd those zeros come from?
The zeros come from right here because we don't use it until right here.
Until the very end. There you go. Good. So we have 2 zeros here, 2 zeros there. That's where they came from, right? Okay, so it looks to me like we've done some pre-math work on this problem. Can you do the real thing now? Let's see if we can all get the actual answer, and it should be close to 4,100. It could also be close to 4,000. Some people rounded to the nearest 100. Could be close to that as well. So see what you get for the real deal. What is the real answer to this problem? Yeah, do the real thing and see if it's close to 4,000. Let's see what happens there. Oh, I see some math going on here. It's a good thing. So 8 times 2, 16, and you carried a 1. Good start. 8 times 1 is 8. Carry the 1, you got a 9. What's that last part? Gotcha. So 4 times 8 is 32. Was there anything that you carried over there? Was there? Is that right? 8 times 1 is 9. Looks like to me like this is a pretty good answer. What answer did you get there? 3,296? Let's go around and see if we have the similar answer on other papers here, or other boards. 3,296? 3,296?
Yeah, I use the same method as
The same method. Now, does that answer make sense? That's the real question we want to look at. Is that answer close to 4,100? Is it close to 4,000? 3,296, 3,296, 3,296. That's pretty good stuff. It looks to me like we did some good rounding here. And it looks to me like we're awful close to where we want to be. So if you had an answer similar to what you're doing there, 3,296 is what we're looking for. But let's say at the very end of this problem, you ended up with 43,296. Is that close to 4,000?
No.
Not at all. And so you know, before you even check your answer, that this answer would be wrong, and there's something wrong before you went to turn in your test, before you went to finish the problem. Now, Jack says that this answer is not close to 4,000. Tell me a little bit about your thinking there.
Because I rounded 3,296 to
Oh,
the
so you rounded the
thousands
answer.
place. So
Yep.
3. So I have a rhyme. It's I forget.
So you rounded the
Find
nearest
the digit.
thousands.
Find the digit. Look next door. Add if 5 or higher, add 1 more. This is not 5 or higher, so
That's
this
right.
is plus 0, so it's 3,000.
3,000.
It's closer.
So you can round at the beginning, or you can round at the end, right?
So
and we can
it's-
compare those numbers.
It's very close to 3,000, and it's
It's very close.
296.
Yep. You could round that one too.
And that's
Jack, we want to see more when we come back, okay? Because you're doing some amazing rounding there. We're going to use some multiplication when we come back and maybe do some area problems to put it all together. Still outside, still enjoying the beautiful weather, but that is no excuse not to do some math. So we're going to head to it. We have 2 more problems we really want to work on, and they are inspired by a couple people that inspired me to do some math. The first one is, if you can all make sure you draw a rectangle on your page here, okay, on your board. We're going to do a little bit of rounding like we did last time. We're also going to be finding the area. So the goal of this problem is to find the area, okay? So let's make sure you have the correct units. So here's the deal. I don't want you to find the real answer. I want you to find the rounded answer. On the top here, let's say that you have 51 meters. That's a big one. And on the right side over here, let's say that this side is 29 meters. Now, what I'd like you to do, instead of finding the actual area, I want you to round both of those numbers, multiply them together, and see if you can give me a rounded answer of what this would look like. Because One of my teachers when I was younger, Mr. Sikowski, used to love to do these kind of problems. This was his thing. He used to like to do some rounding and not actually find the real answer. Let's see what you got. Round each of the numbers and then multiply them together. And don't forget your special units, right? What a wonderful job here. It looks like 51 rounded to 50 and 29 rounded to 30. And we have, what's this number here?
1,500.
Can you tell me what 1,500 represents? 1,500 what?
Square meters.
Oh, I like it. Can you write that down? How do you write square meters? Oh, I like it. There you go. What do we got over here? We got 50. We got 30. People are coming up with the same thing. It looks like you're really good at rounding. And the key at the very end here, make sure you have those correct units, right? Square meters. Some people like to put a meter with a second power up the top, right? Okay, so you definitely know how to do your area of a rectangle, right? Definitely know how to do that. Now we're gonna do some teamwork, okay? Erase your picture. Here's the last one, but this is something you can definitely do. We wanna find the area of this crazy shape, the real area of this crazy shape. So here's what I'm gonna have you do. This table over here, you're only gonna worry about the long, skinny rectangle. Can you find the area of this, please? And here's the numbers. It's 2 meters tall, and it's 8 meters long. You find the area of that part, okay? Over here at this table, can you find the area of the big part of this T? Down here on the bottom, you have 4 meters. And all the way up and down over here, you have 7. That's supposed to be a 7. I'm gonna go ahead and write this way. 7 meters. Can you find the area of this part over here? Just this right-hand side. Okay? And then we'll put your answer together with their answer and see what we get. This is the kind of a problem that Mr. Smith inspired me to do when I was growing up, and I think this is something that you can do as well. So did you find the area of your one part there?
No, but should we work in in a group?
You can work together, sure, but you are worried about this part right here, this top part of the T,
Yeah,
okay?
only that part.
Only that part. Oh, I like the work here. What's the area of this top part of the T?
28. This part?
Yep, just the top part. What do you have here?
4.
Yeah, this is 4, and this is 7, so what'd you get for the area?
I got 28 meters.
28 meters. Is there something else you got to put there? Square. Gotcha. You check with your teammates here. We're going to go to the other table and make sure to see what they got. What do we got here for the long, skinny part here, crew? Oh, I like this. Tell me where 16 came from. Here's a 2.
It came from the...
How'd you get it?
I got it by tying.
You multiplied it. That's exactly it, right? And here's your 8 meters. Gotcha. So this part here is 16 square meters. Okay, work with your table. The long, skinny part is 16 square meters, right? And the big old fat part, what was that? 28. 28 square meters. So we need a total area of the whole entire T. And a total usually means addition. Can you add them together?
Yes.
Jack, I knew you got
I
it.
have it.
I knew you got it.
44.
44? 44 what?
44 meters squared because
Ah, I like
6
it.
plus 8
Uh-huh.
is 14. But
Uh-huh.
you can't do that. So 16. See, 4. You have to carry the 1.
You do, that's
and
right.
1 plus 2 is 3.
I
plus
love how you
1
describe that.
Is
And you got a 4, and the best part about it, you got the meters squared. So much fun. Right before we go, can everybody tell me what's your mascot? The Mustang! There he goes.